Hello, Algebra 1, this is Mr. Green. Today we are talking about Chapter 2, Lesson 7, and the topic is percent change. So our two I can statements, our objectives, our goals for the day. By the time you leave this class or you finish watching this video, you should be able to find the percent change and solve problems involving the percent change. So to start with, what is the percent change? It is the ratio of the change in an amount to the original amount, okay, and it is expressed as a percent, okay. So if the new number is greater than the original number, then the percent change is a percent increase, or it's increased, it's gone up. If the new number is less than the original number, the percent of change is a percent decrease. You see this all the time in the real world. You see things that say there's been a 50% increase in whatever stat, there's been a 75% decrease in the amount of teen smokers, okay, or different stuff like that. Understanding percent change is really vital to being an informed person in our society, because you hear it all the time from different news stories or political sites or anything that you might run into. So if we take a look at example 1, it says determine whether each percent change is a percent increase or a percent decrease, then find the percent change. So first, if our original is 20 and our final is 23, we've gone up, so this would be an increase. Okay, now to actually find our percent change, okay, so percent change is a ratio, okay, or a fraction, okay, and we have the amount of change on top, and on the bottom we have the original amount. So easy enough. On the bottom we know we're going to have 20 because that's the original amount. It says original right next to it, 20. On the top we have the amount of change. Well, how much did it change? For us it's pretty easy to see it's 3. If you did have a more difficult problem, something that's not as straightforward, you would subtract the 2. 23 minus 20 is 3. Okay. Now the easiest thing to do here is to type this in your calculator. Take 3 divided by 20, convert it into a decimal. 3 divided by 20 is 0.15. Now that's the decimal. Okay. Percent change is described as a percent. So our rule for percent, you can either multiply by 100 or just move the decimal 2 places to the right. 1, 2. This is a 15% increase. Okay, and I'll just make a little arrow there for increase. 15% increase. Okay. If we take a look at B, another example, here our original is 25 and our final is 17. Okay, well, 17 is less than 25, so this would be a percent decrease. So whatever we are talking about is going down, decrease. So again, if we take a look, our percent change is the amount of change over the original amount. On the bottom, we know we're going to have 25. Okay, and how much did it go down from 25 to 17? That would be 8. Down 8. So you type in 8 divided by 25, convert it into a decimal, you get 0.32. That's a decimal, convert to a percent, 1, 2 to the right, that would be a 32%, I'm going to rewrite it, 32% decrease. Okay. And there you have it, the percent of change. Remember, the amount of change over the original amount. Okay, go ahead and pause the video and try 1A, B, C, and D, please. It should not take you very long. So pause the video. All right, we should be back from the video. Okay, if we take a look at 1A, our original is 66, our new is 30, so we know that is a decrease. Okay, we have 66 on the bottom because that's our original amount. Okay, and it went down 36, so we put that on top. Okay, type it in your calculator, 36 divided by 66, and we get 0.545, okay, which is rounded. Okay, rounded to 3 decimal places, so you convert it into a percent, and you get 54.5%, and that was a decrease. Okay. 1B, our original is 9.8. Okay, now this is one where it's not easy to see. It's not, 20 and 23 here. Okay, so this one we would want to type into our calculator. Okay, so you can take 12.1 minus 9.8, okay, and you get 2.3. So that's your amount of change. You just subtract the two to find how much change there is. So the amount of change over the original amount, go ahead and divide that. And you end up at, if I round to the nearest thousandths place again, I have 0.235, which is a 23.5% increase. I don't know if you can see that. I'm getting kind of crowded over there. 23.5% increase. 1C. Okay, our original is smaller than our new, so we know it's going to be an increase. The original always goes on the bottom. On the top is the amount of change. 40 minus 24 is 16. We have 16 over 24. Type that into your calculator to get the decimal, which is 0.6 repeating. 0.66, we'll call it 7 and round. Okay, which would be a 66.7% increase. Okay, 66.7% increase. And lastly, over here we take a look at 1D, and I'm going to do it below so I don't run out of room. Our original is larger than our new, so this will be a percent decrease. Our original always goes on the bottom. Okay, and we can take 500 and subtract 131 to get our amount of change, and it ends up being 369. Divide that out to get my decimal, and it ends up being 0.738. Move it 2 spaces to the right, and I end up at 73.8% decrease. That is not very good. Well, maybe it is good. Maybe they're talking about something bad that's going down. The amount of murders is dropping by 73.8%. That's good. Okay. So with that, remember, percent change is always the amount of change over the original amount. If you're not sure, if it's not an easy answer for how much it changed, okay, subtract the 2. Okay, subtract the 2, and your answer will always be positive on top. Okay, because the increase or decrease will tell you whether or not it's going up or down, not the negative or positive sign. So your change should always be a positive change on top. Okay, don't make it negative. Okay. Moving on to our next example here, we have a word problem, a real-world example number 2, talking about percent of change. Here we have the total number of passengers on cruise ships increased 10% from 2007 to 2009. If there were 17.22 million passengers in 2009, how many were there in 2007? So, this one, what we really need to do is kind of work backwards. Okay, I'm going to do this one much different than what your book has, and actually I've been doing everything much different than what your book has. I think it's just easier the way I do it. Please pay attention. What we know is that we end up in 2009. Okay, we know the amount of passengers we have in 2009. We know the percent increase. What we don't know is our original amount. Okay, and if we don't know something in algebra, we assign it a variable. So I'm going to go x equals, okay, the number of passengers in 2007. That's what x will represent, okay, because that's what I'm trying to find. So if I start writing an equation, I know that I'm going to end up at 17.22 million passengers. But how did I get there? That's what I'm concerned with. How did I get there? I started with the number of passengers in 2007. And then I added, okay, a 10% increase. Well, how do you find 10% of the passengers in 2007? Well, the key word is of. When we talk about of, that indicates multiplication. So I take 10% times the number of passengers in 2007. Okay? And 10% as a decimal is 0.1. I multiply that by the number of passengers in 2007, which is represented by X. Okay? Now, what I have here are like terms. I have X plus 0.1X. Okay? Well, this is, our coefficient on X here is a 1. Now, we don't write it, it's an implied 1. Just like our exponent is a 1, it's an implied 1, we don't need to write it. So I have 1X plus 0.1X. I can add these together because I have this same variable, they're like terms. I have 1.1X is equal to 17.22. Now all I need to do is solve this equation, and I do so by dividing by 1.1. So I take 17.22 divided by 1.1, and I end up at 15.65, okay, and that is rounded, 15.65, and my label is million passengers. Okay, so you kind of have to think about the information you have and how did you get there? How did we end up at 17.22 million passengers? Well, we started at what we had in 2007 and we added a 10% increase of that. Okay, from there we just solved the equation and we end up at 15.65. Go ahead and pause the video and try number 2 on your own, please. Try number 2 on your own. Okay, we should be back from trying number 2 on our own. Let's go through it. It says, a recent percent of increase in tuition at Northwestern University in Evanston, Illinois was 5.4%. The new cost is $33,408 per year. Find the original cost per year. So again, just a bit of advice when we're solving word problems, generally the last sentence tells you what they're looking for. It says find the original cost per year. Okay, so if that's what we're trying to find, that means we don't know that currently. Okay, and if we don't know something in algebra, we assign it a variable. X equals original cost. So what we had is we had our original cost. We added a 5.4% increase to that. So 0.054x. That's how we find the amount of that increase. We take the percent, written as a decimal, times the original amount, and we ended up at 33,408. Okay, well, just like before, if you have 1x plus 0.054x, I end up, I'm going to write it over here because I'm running out of room, 1.054x equals 33,408. Now it's a simple equation that all we have to do is divide by 1.054 on both sides. And we should have x to b. Type it in here, 33,408 divided by 1.054. We should get $31,696.39. Okay. And that is our original amount. Moving on, we have another type of word problem. Okay. So here is our second part, solving more real world problems. 2 applications of percent change are sales tax and discounts. We see this all the time. Anytime you walk into a store, it's a 20% discount, a 20% off, or things like that. So sales tax is an example of a percent of increase, and discount is an example of percent decrease. Sales tax adds cost to your items. Discount subtracts cost, okay, or makes your cost go down. Okay. So here's a couple examples. The first one. Marta is purchasing wire and beads to make jewelry. Her merchandise is $28.62 before tax. If the tax is 7.25% of the total sales, what is the final cost? Okay, so we're looking for our final cost here. In this one, it fits a little bit easier just to make an expression that simplifies down to our final cost. Okay, but what we have is our total amount, and we need to multiply that by our tax percentage. That will give us the amount of the taxes that we are going to pay. So we take 7.25% written as a decimal, and we multiply it by 28.62, and that'll tell us how much tax. Okay, so if I take 28.62 multiplied by 0.0725, okay, this will give us our amount of tax. Okay. Now, that's not what I'm going to pay at the register. I don't only pay the tax, I also have to pay this original amount. So I add it again to this original amount. Okay. Now, when I simplify this, this will give me my answer. Okay, so if I multiply this out first, I have 28.62 times 0.0725, and I get 2.07, okay, rounded, plus 28.62, okay, and that comes to be $30.69. Now, this way makes the most sense to me. Here is the tax, here is the total before tax, or the total cost beforehand, or just the cost, really, cost of items, maybe I'll say. Okay, so you have your cost of items, then you have to pay the tax on that. You add those together to get your total cost. Okay. There is a shortcut. Okay, when we're talking about tax, okay, you need to add it to the original amount. Okay. So what we can do, instead of multiplying by 0.0725, you could multiply by 1.0725, because that's including the 28.62. And if we take a look at this as a binomial, 28.62 times 0.0725 plus 28.62. I can do a reverse distributive property and factor out a 28.62. So I have 28.62, and when I factor out, I'm essentially dividing. So if I divide this first term by 28.62, all I have left is 0.0725, and over here I have 28.62 divided by 28.62, which is 1. So really what I have is 28.62 times 1.0725, okay? And when I multiply that out, times 1.0725, I get the exact same answer. So this is a shortcut, and please do not think you have to factor it out every time. It's a shortcut to know that you can just take 1 point and then your percent of tax or your percent of increase, okay, and that will give you the total amount right away. So if you are a person who really knows what's going on, you're kind of street smarts, I would say, this is how you would do that in one simple step. Okay, here is the math why you can do that. That is why you can have the shortcut, but this is the shortcut. Now, if that doesn't make sense to you, if you can't remember that, do it this way. Okay, I feel it's pretty easy to remember. You take your total cost plus the amount of tax to get, or your cost of all your items plus the amount of tax to get the total cost. Okay, you can do that, and you know what? It's one extra step. It's not a bad method, but this is a shortcut that a lot of people will use to do that. So go ahead and pause the video and try number 3 on your own. So we should be back from our break, and you should have tried number 3. Let's go through it. A new DVD costs $24.99. The sales tax is 6.85%. What is the total cost? So here we take the amount of tax, which is 24.99, times the 0.0685, and we add that to our original amount, 24.99, Okay, and that will give us our total cost. 0.0685, which is 1.71 rounded, plus 24.99, and I get $26.70. Okay, now if you're a shortcut person, all you need to do is take 24.99 and multiply by 1.0685, okay, and you'll get the same answer of $26.70. Two methods, same answer. The choice is yours. Whatever is easier for you to remember, I suggest doing. Okay. Moving on, now we need to go the other way. Here, before we talk about sales tax, when we add cost to our total, now we talk about discounts, the sales, the bargains that everybody loves. So here we have Tyrell, and he has earned good grades in school. He qualifies for the good student discount on his car insurance. His monthly payment without the discount is $85. If the discount is 20%, what will he pay each month? So what we can do is the same thing as we did before. So we take 85 and we multiply it by the amount of the discount, okay, as a decimal. 20%, 0.2. Okay, this represents the amount of the discount. Now, we need to subtract that from our original amount. So I should have wrote this over a little bit more, but I will subtract this from our original amount, $85. So I take $85, the original amount, subtract the amount of the discount, and that will get me my total cost. Okay, so down here, 85 minus 85 times 0.2 is $17. Okay, 85 minus 17 is equal to $68. So, nothing too difficult there. Calculate the discount, subtract it from the total. Now, again, there is a shortcut to doing this, okay, and it follows the same model as before. Just like before, when we could factor out and add our numbers together, here we can factor out and subtract our numbers together. So I'm going to bring this over here. Okay, rewrite it as 85 minus 85 times 0.2. If I factor out an 85, put it out front, what I have left is 1 minus 0.2. Well, what's 1 minus 0.2? 0.8. Okay, well, 85 times 0.8 is $68. Okay, so again, you can remember this shortcut, and I think the easiest way to remember that is if you're taking 20% off of your total cost, what percent of the total cost are you paying? Well, you're paying 80% of the cost, right? So you just multiply it by and find 80% of the cost, and that's how much you're going to pay. Okay? Now, does it save you a whole lot of time? Not really. Okay? But it is something that you can use in your daily life, okay, to help you calculate these things a little bit quicker. If you might not have a pen and paper to kind of write all this stuff out, you can just take 85 times 0.8, and there you go. Okay. So go ahead and pause the video and try number 4 in a guided practice. Try that one on your own. And we should be back from our break, so let's go ahead and try number 4 here. It says a picture frame originally priced at $14.89 is on sale for 40% off. What is the discounted price? So if we start with our original amount, $14.89, we subtract our discount from it, $14.89 times 0.4. Okay, we take 14.89 times 0.4, and we see that the amount of our discount is $5.96 rounded. Okay, so I take 14.89 minus 5.96, and I get $8.93. Now, once again, there is a shortcut. So if there is 40% off, what percent am I paying? I'm paying 60%. So what is 60% of 1489? Okay, you take 1489 times 0.6, and you get $8.93. Once again, two ways of doing it, but you get the same answer. That will do it for this lesson. Here's your assignment. We're on page 22. We're going to do 14 through 38 all, 40 and 42. Have a great day and get your homework done.